I'm going to evaluate the integral of x cubed y cubed divided by 3 dx plus x to the power 4 y squared divided by 2 dy along the closed curve C in the positive direction, where C is the boundary of the region in the first quadrant bounded by the graphs of y equals to x, y equals to 0, and x equals to 1. So we are given this integral here. To evaluate this integral, I'm going to use Green's theorem. Green's theorem states that if C is a piecewise smooth, simple closed curve bounding the region R, P, Q, partial derivative of P with respect to Y, partial derivative of Q with respect to X are continuous on the region R, then the integral of P dx plus Q dy along the closed curve C in the positive direction is equals to the double integral over the region R of the partial derivative of Q with respect to X minus the partial derivative of P with respect to Y dA. So comparing the integral that we are given, we are having a P dx here, and on the other integral there, we are having x cubed y cubed over 3 dx. So by comparison there, we see that our P is equals to x cubed y cubed over 3. Then go on and compare this part here, the Q dy. Here we are having x to the power 4 y squared over 2. So by comparison there, we see that Q is equals to x to the power 4 y squared divided by 2. So we now have our P and our Q. We go on and evaluate the partial derivatives. The partial derivative of P with respect to y is equals to x cubed multiplied by y squared. The partial derivative of Q with respect to x is equals to 2x cubed multiplied by y squared. So those are the functions that we have. Then we go on and substitute them into our formula here so that it will give us the double integral over the region R of 2x cubed y squared minus x cubed y squared dA. We can simplify that because 2 minus 1, it gives us a 1. So therefore, the double integral over the region R of x cubed y squared dA. So that's the integral that we have now. We go on and look at the region that we are given. So for the region that we are given is the region bounded by these curves. So I can just plot that. So I can have my x-axis there, and then label it the x, then put a 0 here, and then draw the y-axis, then label it the y there, then draw the line y is equals to x. It's a straight line. Then I label it y equals to x. The line y equals to 0 is the x-axis, so it's already there. And then I put on the point x equals to 1, and then plot the line x is equals to 1. This one here, so I will label there x is equals to 1, and then label the 1 there on the y-axis. So the region that is bounded by these lines there is this one here that I've just shaded. So that's our region R there. And inside this region there, x is varying from 0 to 1 there. So I can write it down there in the region R, x is varying from 0 to 1. And then go on and look at the y there. The y is varying between these lines. So y is varying from 0 to x in the region R. So those are the limits there. So drawing the graph there helps us to see the limits of integration clearly. So we then go on and try to evaluate that double integral there. So when you are evaluating double integrals there, we put the integral with the constant limits outside, then the integral with the variable limits, we put it in the inside. That's the one that we evaluate first. So in this case, we are seeing that the y there is the one that has variable limits, so it's the one that we evaluate first. So having the integral from 0 to 1, the integral from 0 to x of x cubed y squared dy dx. So we are evaluating this integral first, the one with respect to y. So I can just write there the integral there from 0 to x of x cubed y squared dy. We are integrating with respect to y, treating x as if it's a constant there. So our result will be x cubed y cubed over 3, then put the limits 0 to x. So when we put the limits there, we get x cubed times x cubed divided by 3 minus x cubed times 0 cubed divided by 3. which will simplify to x to the power 6 over 3. So this result here is what we substitute on the highlighted part here. So our integral becomes the integral from 0 to 1 of x to the power 6 over 3 with respect to x. Then we go on and evaluate that integral there. And when we do that, we get the result x to the power 7 over 21, then put in the limits 0 to 1. So our result there will be 1 over 21. So that's the result there of our line integral.